Hello everyone, welcome to the lecture again. In the last couple of lecture, we analyzed cables in two cases. In the first case, the loading was uniform along the horizontal direction, and in the second case, the cable was hanging under its own weight. We saw that the equation of the cable in the first case is parabola, and in the second case it was catenary. Now let us look at various examples. So, this is the first question statement. A uniform 80-meter pipe that weighs 960 kilonewton is supported entirely by a cable AB of negligible weight. Determine the length of the cable and maximum force in the cable. So, first, since the cable is supporting a uniform weight along the horizontal direction, therefore, the equation of the cable will be the parabola. So, this comes under the first category. Let me first make the free body diagram of this system. So, we have this cable and this is point A, point B, and this is supporting a uniform weight. Let us put the axis at the bottom point of this cable. So, this is the x axis, the y axis, this is 80 meter, this height is 7.2 meter and the weight is 960 kilonewton. This is given 20 meter. Let us say this length is LB and this length is SB. Now, the weight per unit length, which we denote by small w, will be 960 kilonewton divided by 80 meter. So, this will be 12 kilonewton and this is nothing but weight per unit length. Okay. Now, as I said, the equation of the cable will be parabola. So, let us use the equation y equal to w x square over 2 T naught. Now, here T naught, remember this was the tension in the horizontal direction and it was constant. Okay. So, T naught was the tension in the horizontal direction. Okay. Now, to determine let us say x, let us use the boundary condition. So, we can see here that for y equal to 7.2, that is for point B. So, we have 7.2 equal to W is 12 kilonewton and x is LB. So, therefore, this will be LB square over 2 T naught. Okay. So, this is equation number 1, this is for point B. Similarly, for the point A, we have y equal to 20 equal to 12 kilonewton, which is W, into x. X is 80 minus LB square because the entire length is 80 meter. So, this will be divided by 2 T naught. Okay. Now, to determine LB, let us divide equation number 2 to 1. So, we get 20 divided by 7.2 equal to 80 minus LB square over LB square, and this gives me 80 minus LB over LB equal to 1.666, and this will give you LB equal to 30 meter. Therefore, LA will be 80 minus 30 equal to 50 meter. Okay. So, therefore, LA will be 50 meter. Now, let us find out what will be the maximum tension. So, in the question statement it has asked the maximum force. So, let us find out the maximum tension in the cable. So, remember T max was WLA square root 1 plus LA over 2 HA whole square. Now, here we have used x equal to LA because that is where the maximum tension will be, because that is the highest point in the cable, not LB. So, let us put the values. So, this is something that we have derived. So, this will be 12 kilonewton into LA is 50 into square root 1 plus 50 divided by 2 into 20 whole square. This will be 600 kilonewton into square root 1 plus 25 by 16, and this will comes out to be 960 kilonewton. Now, let us also find out what is the length of the cable. So, remember we have the following setup: you have this weight, then you have this cable, and this is the minimum point, x axis, y axis, this is 50 meter, point A, point B, this is 30 meter, and let us call this SA and this equal to SB. So, this is 7.2 meter and this one is 20 meter. Now, to find out the entire length, we have to sum SA and SB, and we know how to calculate SA. So, this will be LA into 1 plus 2 by 3 HA over LA whole square plus the second term plus LB into 1 plus 2 by 3 HB over LB whole square plus dot dot dot. Now, remember we can use this formula only if HA over LA is less than half and HB over LB should also be less than half. Let us see if this is true. So, here our HA is 20 meter and LA is 50 meter, and this is indeed less than half, and in this case it is 7.2 meter divided by 30, which is again less than half. So, therefore, this formula we can use. Okay. So, I have taken only the second term, but to get the exact value of S, you can take third term and fourth term also. So, this will be 50, 1 plus 2 by 3, 20 over 50 whole square plus dot 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 plus 30 into 1 plus 2 by 3, 7.2 divided by 30 whole square plus dot dot dot. So, let us simplify this. This will be 50 plus 2 by 3 into 400 divide by 50 plus here I have 30 plus 2 by 3 into 7.2 to 7.2 divide by 30, and this comes out to be 86 meter. So, this is the length of the cable. Now, let us look at the second example on the same concept, and here the problem statement is following. The light cable supports a mass of 12 kg per meter of horizontal length and is suspended between the 2 points on the same level 300 meter apart. If the sag is 60 meter, find the tension at mid length, the maximum tension and the total length of the cable. So, again you can see here that the cable is supporting a uniform weight along the horizontal direction. Therefore, the equation of the cable will be the parabola. Now, let me first make the diagram. So, we have this cable and this cable is supporting a uniform weight. This is our x axis, this one is the y axis, this is given 300 meter. Let us say this point is A and this point is B. So, the weight per unit length is 12 kg per meter. This height is 60 meter and let us say this length is LA and this is of course HB equal to HA, and let us call this equal to SA and the other one will be SB. So, let us use the equation of the parabola. This is y equal to W x square over 2 T naught. Now, in the question statement it has asked you to find out the tension at the mid length. Okay. Now, the tension at the mid length will be T naught. So, let us find out what is T naught. So, from here you can see that T naught will be W x square over 2 y. Now, to find out T naught, let us use the boundary condition. Okay. So, let us use boundary condition, and for that I am going to use point A. Okay. So, at point A, T naught will be T naught because that is just the horizontal component equal to W, x will be LA. So, we have LA square over 2, y is nothing but HA, and we know the value of LA and HA. So, let us put it back. So, T naught will be W is 12 into 9.81 into LA is 300 divided by 2. So, it will be 150, but let me just write down 300 divided by 2 into 300 divided by 2 into 2 HA, 2 into HA is 60 meter. So, that much Newton, and you can simplify it, it will comes out to be 22.1 kilonewton. Now, let us find out what is the maximum tension. So, maximum tension, so this is T max. So, T max will be W LA is square root 1 plus LA over 2 HA whole square. Let us put the values. So, it will be 12 into 9.81 into 300 divided by 2, which is my LA, into square root 1 plus LA is 300 divided by 2 and 2 HA. So, 2 into 60 whole square, and again you can simplify it, it will comes out to be 28.3 kilonewton. So, we have find out the value of T naught and T maximum. Now, let us calculate the length of the cable. So, from here you can see that the length of the cable will be 2 times SA. So, the length of the cable will be 2 times SA, and let us find out what is SA. SA will be LA 1 plus 2 by 3 HA over LA square. Now, I am also going to take the third term minus 2 by 5 HA over LA to the power 4. If you want, you can ignore this. Now, again let me emphasize, to use this formula I have to make sure that HA over LA should be less than half. So, let us see, my HA is 60 and LA is 150, and this is indeed less than half. So, therefore, I can use this equation. So, this will be 150, 1 plus 2 by 3, HA is 60 divided by 150 square minus 2 by 5, HA is 60 and LA is 150 to the power 4 dot dot dot, and this comes out to be 164.5 meter. Therefore, the length will be 2 into 164.5, this will be 329 meter. Now, these two examples, as I said, they were related to a uniform loading along the x direction. Now, let us discuss the case where the cable is hanging under its own weight. Okay. So, this is one such example, and let me write down the problem statement. So, this question is related to the previous question. Question number 3. In the previous problem, the horizontal load is removed and the cable is replaced by a cable which has a mass of 12 kg per meter. So, earlier the cable does not has mass, or the mass was negligible. Now, the mass of the cable is 12 kg per meter. Find the tension at mid length the maximum tension and the total length of the cable. So, as I said, because this cable is hanging under its own weight, therefore, it will follow the equation of catenary. Let me write down the equation of catenary for the cable that we have derived. So, y will be T naught divided by mu cos hyperbolic mu x over T naught minus 1. Okay. So, to find out T naught, let me use the boundary condition. So, this is to find T naught, we are using the boundary condition, and for that let us say this point is, okay, let me just make the free body diagram once again. So, we have this cable we put the coordinate axis at the bottom point. So, this is x, this is y, and from here the cable is hanging. Let me call this point A, this point B, and this is given that it is 60 meter, this is 300 meter. So, let us use the boundary condition at let us say A point. Okay. So, at A you can see that y is 60 and x is 300 divided by 2, which is 150 meter. Now, let us put it back into the above equation. So, we have 60 equal to T naught divided by 12 into 9.81 into cos hyperbolic. Mu is weight per length. So, this is 12 into 9.81 into 150 divided by T naught minus 1. Let us simplify it. So, this will be 7060 divided by T naught equal to cos hyperbolic 17660 divided by T naught minus 1. Now, this equation is not easy to solve. So, therefore, what we can do is we can solve it graphically, and for that let us plot both the side, and then the intersection of both the plots will give you the solution for T naught. So, let us assume that this is y. So, what we are going to do is we will plot this, we will plot that, and then their intersection will give you T naught. Okay. So, this is how this equation can be solved. So, on this side you have T naught, and you can plot 7060 divided by T naught. So, let us say this is one plot, and for the second one this is the plot. So, this you can do in the computer, and the intersection, as I said, this will give you the value of T naught. So, let us say this is cos hyperbolic 17660 divided by T naught minus 1, and this is 7060 divided by T naught. Okay. And if you do that, you find out the intersection. So, the intersection gives you T naught equal to 23200 Newton, which is nothing but 23.2 kilonewton. So, this is T naught. Now, let us find out the maximum tension in the cable. So, again we have derived the formula for the maximum tension. Maximum tension, you can use T equal to T naught plus mu y, and for the maximum tension you have to maximize y. Let us see what is the maximum value of y. The maximum value of y is 60. Okay. So, therefore, T maximum will be T naught, and T naught we have just find out, this is 23200 plus mu is the weight per unit length. So, this will be 12 into 9.81 into y is 60. Okay. So, this comes out to be 30263 Newton, or this is 30.26 kilonewton. Note that you can also find out the tension by using T equal to T naught cos hyperbolic mu x over T naught, and here for T maximum you have to put x maximum, and the maximum value of x is 150. So, you can also find out T max using this formula. Now, let us find out the length of the cable. So, the length of the cable, you can see it will be 2 times S. So, let us say this is S or SA, then it will be 2 times SA. So, the length will be 2 times S, and we know the formula for S, because S was T naught over mu. sine hyperbolic mu x over T naught. Again we have derived this formula. So, therefore, 2s will be 2 times T naught is 23200 divided by 12 into 9.81, this is the weight per unit length, sine hyperbolic 12 into 9.81 into 150 divided by T naught, which is 23200, and you can solve it using calculator. This will be 330 meter. Now, let us look one more example on the cable which is suspended under its own weight. So, here the problem statement is as shown in the figure, a 36 meter cable with mass 1.5 kilonewton per meter is hanging between point A and B. Determine the sag H and the maximum tension in the cable. So, let us find out the sag. Now, to find out the sag, let us first find out what is T naught, okay. And to find out T naught, because here S is given, the length of the cable is given. So, let us use the formula for the length of the cable. So, we have also derived this S equal to T naught divided by mu sine hyperbolic mu x over T naught. Okay. And as I said, to find T naught, because that is constant, this is tension along the horizontal direction. So, let us use the boundary condition. You can either use A or B because that is symmetric. So, at A or B, S is 18. So, we put our, you have this cable, this is point A, this is point B. Remember, you have to put the origin at the minima. So, therefore, this will be 18 meter, this will be 18 meter, and this is 15 meter, and this is also 15 meter. Okay. So, S here is 18 meter equal to T naught divided by mu. Mu is 1.5 kilonewton per meter. So, this will be 1.5 sine hyperbolic mu is 1.5, x is 15 divided by T naught. Now, let us simplify this. So, this will be 27 divided by T naught equal to sine hyperbolic 22.5 divided by T naught, and again this equation can be solved graphically. So, either you can use computer or you can plot both the side in the graph and you can find out the intersection. The intersection will give you the value of T naught, and T naught comes out to be 21.13 kilonewton. Now, let us find out H. So, to find out H, let us use the equation of catenary. So, the equation of the catenary was y equal to T naught divided by mu cos hyperbolic mu x over T naught minus 1, and to find out y we have to use the boundary condition. So, let us use the boundary condition either at point A or point B. So, at point A or B, y is h equal to T naught is 21.13, divide by mu, mu is the mass per unit length which is given, it is 1.5, and cos hyperbolic 1.5 into x, x is 15 meter, divide by T naught, we have find out this is 21.13 minus 1. So, this can be solved in calculator and it will be 8.77 meter. Now, let us find out the maximum tension in the cable. So, maximum tension in the cable for T max, T will be T naught cos hyperbolic mu x over T naught. You can also use T equal to T naught plus mu y, but this is the one that we used in the previous question. So, this time let us use this formula. So, T max will be T naught which is 21.13 cos hyperbolic mu is 1.5 into x. So, T maximum will be at the boundary. So, at the boundary x is equal to 15 meter. So, again either point A or point B into 15 divide by T naught, T naught is 21.13 and this will give you 34.3 kilonewton. So, with this let me stop here. Thank you.